Hello, good morning, good evening, everyone. So we'll wait for 5 minutes, and after that we can start the session. Anyone confirm me? My screen is visible or not? Am I audible to everyone? Anyone can unmute and confirm me. Am I audible? Hello? Or you can chat also in the chat box. Am I audible?
Yes, you are audible, sir.
Oh, okay. Thank you. So it's already 6:05, so I think we can stand. And my screen is visible to everyone. I am presenting some PPT, so is it visible? Hello? Hello? Someone can unmute and can you confirm that my screen is visible or not so that then we can start.
Yes, sir.
So I have presenting some electrochemistry PPT. So is it visible?
Yes, sir, it's visible.
Okay. Thank you. Okay, then I think we can start. I don't know how many students is there in this course. But as it is the time to start, so we can start. Okay. So, yeah. So, good evening, all. So myself Suhankar, I am a integrated PhD student in Indian Institute of Science. So I am basically one of the TA of this course. So I don't know how this course is to run in online, but the Professor Madakavi, who is the instructor in this course, so uh, in this course, basically, we'll discuss like, what we have learned in whatever professor have taught. So that things will sum up, and with that, we'll discuss some of the what is called question answer, which can help how we can tackle the question when sometime something related to that question will come or that topic it will come in your exam or in your assignment. Okay, so with that we can start with electrochemical technology in pollution control. So usually I am working in electrochemistry, so basically energy storage system like okay, some guest is to come in the lobby, so if people can add me in them, okay, because I did not able to see when I am presenting this slide. So if anyone is waiting in the lobby, then if people can admit them. Okay, so basically, what we'll learn in this course is that how we can use electrochemical technique in pollution control. Then different type of electrochemistry related topic and how it is to work and how renewable energy can use to decrease or to control the pollution or global warming which coming from the due to the pollution. Okay, so I used to work on the energy storage system like battery basically. So beyond lithium ion battery, so which such as lithium oxygen or in metal air battery. So when we will discuss in one part is there the battery technology which can be used to control the pollution or which can compensate the pollution. Okay, so that time we can discuss battery metrology or renewable energy source. So that we will discuss in details. So this is the content in our key course, what we will learn from there. So this is a 8-week course. So in 8-week course, so today we'll little bit discuss about the introduction and the atomic structure, which can help to understand the electrochemistry or when the redox process will happen in the system. So that time how in the atomic scale level what is happening in the system and how the redox process is happening, so that kind of information will understand, and why redox process should happen, all these things. Okay. And along with that, when we will do in solution state electrochemistry, so that time we should know the properties of the solution, how we can make the solution in different concentrations. So this is kind of school level chemistry we'll discuss. And with that we'll discuss the electrochemistry basic of titration, all these things, and some voltammetry and polarographic technique which can help to detect the amount of pollutant in the solution, like water pollution it is to happen. So in our country or overall in the world, so that things will understand via electrochemical technique. And as I mentioned that battery technology will discuss, so that thing. So I will basically sum up what we have learned in this week. So that things we will sum up, and after that we will discuss some question answer which is there in the previous year, as well as I have added some question which is important in different competitive exam, like joint entrance or JEE main, all these things. So different type of competitive exam, also chemistry related question is to come. So if that question is came in this topic related, then we will discuss that kind of question also. Okay. So with that, so this is basically key. Before going to that, what is pollution? As we have discussed, our professor have discussed. So technically, environment pollution is thought to originated from the dust, chemical, or their interaction with the microbiological species such as bacteria, virus, or algae, so fungi, etc. So this kind of system, if it is there in the natural system or natural system such as air or water in that system, then we can tell that it is a pollution. So if you see, I used to stay in Bangalore. So this is the data which I have taken 2020-21 annual report of pollution control board Karnataka. So there, this is basically the water pollution data. So they have taken in different river in South India, like Kaveri, Godavari, or Krishna. So different river they have taken the water, and they are quantifying that how the what is called level of the water or pollution level in the water. So they have categorized in different year. So from 2016 to 2021, this is the data of water quality in different river in Karnataka. So here you can see A, B, C, D, E. So different what is called different categories they have divided. So this A, B, C basically you can see in different categories. So if class A, class B, class C, D, or E. So this is if it is class A state, that means that drinking water, or we can say the sweet water, so drinking water source without conventional treatment, but after we can drink that water after disinfection, because in the water you have some bacteria or some other things, so you can de-inspect it and after that you can drinking the water. And class C or class B is the outdoor bathing water. So it is that the data is representing that. So this you can see that this A in the graph. So here you can see 2026 or 27 there is 2% of 2 was there, but in present time or 2020 to 21 data there is 0. That means the water of the river which is pollutant due to the injection of different organic or what is called chemicals or different type of soap, whatever you are using from industry as well as in the locality. So it is okay. So I think someone is there. So all people are able to join in the. Okay. I think I should admit them. Okay. Okay, so this data means it is represented with time as the time is going. So the pollutant of the pollution level or pollution in the water is increasing. So this is the recent time data, and that is called. There is another data I will present. This is today's data in what is called Central Pollution Control Board of India. So this is data representing that this is the all air pollutant. So this is some data from Delhi. So it is representing that in the air, what is the amount of different pollutant, how it is increasing. So these things you can see that if hello. Yeah, if anyone want to ask question, they can unmute and stop me. Or if you don't want to ask any question, then you can keep mute. Okay. Okay, so let's start. So this is the morning time today morning when I am making the slide. That time I got this data. So here this is around 10 a.m. I have taken. So here you can see that this micro 2.5 p.m. So this is a particle material. So if this kind of particle is there in the air, then your health or here what is the condition can be happen in your health. So if it is an green color ozone or ammonia is there and it is very less amount, then it is minimum good or you can breathe properly. So if it is what is called red kind of thing, so this pm particle, so this is 10, that is basically represent the size of the particle. So different kind of pollutant particle size it is representing. So here you can see that with time when at 10 a.m. so this particle size is increasing, maybe due to the car when this is the office time. So people are going to the office by via car. So maybe due to that the this kind of particle is increasing. So that means due to the car or different kind of fossil fuel burning, so it is increase the pollution in the air, so which can affect our health, so like respiratory illness or prolonged exposure or breathing discomfort. So all these things can be happen, so in if there is a pollution. Now question, so it is important to know how this pollution is happening and how we can control this pollution or how we can decrease this pollution. So that kind of thing we should know. So in this realm, this electrochemistry technique is one of the easiest or very user friendly technique which can give easily the information about the what is called pollution amount, how much amount of pollution or level of pollution is there. So that kind of information we can get easily from the electrochemical technique. Okay, so these things is there. So with that, what we can know that what we should do with this. So what we have to do to know this pollution control, or suppose you are in that topic, and what you have to do. So for that, what you have to do first, you have to identify or determination of the pollutants or the extent of pollution. So means how much pollution pollutant is there in the air or in the water, and how that kind of, and what are the pollutant is there. So that kind of identification is required, first step. Second step is the technical intervention. So how we can what is called compensate or decrease this pollutant amount in the air as well as water or soil, and the post intervention evaluation. So that kind of thing we have to do. So basically what we can do, that this electrochemical technique you can use in this purpose, and how how much amount or minimum amount of pollutant is there, or maximum amount of pollutant is there, and what is the safety level in pollutant. Because in water, in our body, you can also consume the pollutant, but there is some safety limit. Up to upper, if it is above that value, then it can affect our health. So that kind of thing. So we have to know how we can control this thing. So in this purpose, there electrochemical technique or different other technique also there. So basically electrochemical technology or technique is one of the earliest instrument method to analyze this kind of pollutant in the water as well as in air or in the soil. And electroanalytical technology so is great important for pollution monitor. So different type of instrument is there to control this to know the amount of the pollutant in the water or other solvent. So in this purpose, different type of chemical sensor is developing in recent time, and different type of catalyst or or organo-based metal complex also also developing, which can specifically coordinate or interact with the pollutant component to know how how much amount of pollutant is there with current response or voltage response or different type of other term like impedance. All this thing is there which can give you the information about the amount of pollutant, or different type of voltammetric titration technique is there which can give you the information of pollutant amount. Okay, so I think these things is there. So this is the one type of different technology in electrochemical electrochemical techniques, where you can use to decrease the pollution, or to decrease the use of the fossil fuels. And because in nowadays in India government also more interested in renewable energy source, or such as electric vehicle. So Ola Electric or Mahindra, all this company electric vehicle company which are developing this kind of what is called electric vehicles, which can be used for without any fossil fuels, so that we can decrease the amount of CO2 or global warming in the world. So in this contest fossil fuel cell battery technology is the energy source or solar panel, all these things which can use to store the energy from the renewable sources, and which can be used for electric vehicle or whatever we are using in day-to-day life, like mobile or laptop, all other things where we can using battery, all these things. So that can be help to decrease the use of the fossil fuels as well as other things also. So all these things, I think, professor have discussed more details, and I'm not going to discuss more what is called details. I just summing up so that when we'll what is called discuss the question answer, that time we can easily correlate, or maybe we can easily okay, we can easily means do the question answer or related to that. So basically we are recall whatever you have learned in the class, so that kind of things. Okay, so I think this is the thing. So this introduction part on this basis. So we get in our course all these things is there: potentiometry, technique, maybe cyclic voltammetry, and some other technique like polarography. So all this technique we will learn, and the conductimetry technique. So here you can measure the conductance of the solvent or molecule, solvent, all these molecule, and different type of voltammetry, whatever I have written. So basically you current versus voltage, how the system is response during that potential application. So all these things will know, and how the electrochemical sensor can detect the pollutant in the solution. So that kind of information also we'll learn. And one of the technique how we can store the renewable energy source, so battery technology. So that thing also we will learn. So all this, and at the end we'll learn process waste handling of the pollution control. So all these things in this course we'll learn. So my job is to discuss this whatever we learn in the class. So shortly we'll discuss that thing, and with that we'll discuss some of the question in the previous year, or different related to that topic, different kind of questions, so that we can understand the topic more easily and more deeply. Okay, so and after that introduction, we'll discuss a little bit whatever we have learned atomic structure. So in Dalton theory first, we will discuss the Dalton theory. So in modern theory, atomic structure is based on the Dalton theory. So what he proposed that in the in his theory, he is telling that the atom or molecule, what is the atom or what is the molecule, all these things. So basically atom, basically real particle called atom, which is individual, and it cannot be cannot be created or cannot be destroyed. So basically if you have one atom, so you cannot control what is called destroy that atom, or it can be transformed to other atom, but it cannot completely destroy it. So in the Dalton atomic model, so this is the three atom is there. One is hydrogen, which has one electron, and one is helium, which has two electron, the atomic number is 2, and lithium, which has 3 atomic number. So there is the atomic number. So atomic number is kind of number where you can represent each atom, and for every atom there is different or unique atomic number is there. So this is basically the Aadhaar card of the Aadhaar card of the atom. So where I think someone is there in the lobby. Okay. Okay. So basically whatever is there, this is basically the Aadhaar card in easy way you can tell the Aadhaar card of the atom. So this atomic number for each atom has different atomic number. So two atom cannot have the same atomic number. Okay. So atomic number, each atom has different atomic number. Okay, so but in what is called Dalton theory, he did not mention that in the atom, inside the atom, what is there. So he did not mention about that, but he has mentioned that this atom, or what is atom, that is very small tiny particle which is has means it cannot be destroyed or it cannot be created. Okay, then after that Rutherford models came. So in Rutherford's model, what he has mentioned that in the center there is a positive charge is there, and around that there is a negative charge is there. So but it is so basic, it is not also told so many things, but in the Bohr atomic model which can give more more information about the atom. So although there is a some what is called limitation is there also in Bohr model, but still it can be more what is called giving more information about the atom. So what he mentioned that in the atom there is a nucleus is there. So in the nucleus there is a positive charge is there, as well as negative sorry, not negative, neutral particle also there. So neutral particle is there, and in neutral particle around that there is negative charge which is known as the electron. So this electron is roaming as a confinement state. So for each particle there is a one confinement circle is there, spherical kind of circle is there, and in that circle this electron is roaming around the electron. So this table they have mentioned that stable three particle, one is electrons and protons and neutrons. So electrons is the negative charge, electron is negative charge, and proton, which is proton is basically the opposite of electron, that is the positive charge, and its mass, it has a mass. Electron has mass, so proton also have mass, and its mass is opposite to the charge is opposite to each other, and its mass is equal to each other. But the neutron, which is the neutral molecule, neutral not molecule, neutral particle I can say, and what is called, it is a neutral molecule and it has the mass. Okay, so anyone can mention that what is the charge of the electron? Charge of electron. Anyone can tell? Okay, so we will discuss in this way that what is the charge of electron. So the value. It is very easy question. So you can write in the chat box, or what is called. You can unmute also, and after that you can tell also. What is the charge of electron?
1.6 into 10 to the power minus 19 coulomb.
Okay, 1.6 into 10 to the minus 19 Kelvin.
Coulomb.
Okay. And what is the mass of the electron?
- 9.1 into 10 to the power minus 24 grams.
9.1 into 10 to the minus 3124 gram. Okay. Yeah. So that is the thing. So means if electron has a negative charge, then proton have a positive charge, but the mass is same. Okay. So that things we will get to know from the Bohr model. But in next, there is a modern atomic theory where you can tell more in what is called more precisely what is there in the atomic atom. Inside the atom there is a positron and electron, anti-electron, all these things you can get to know. So here you can discuss whatever we have learned from there. So you can discuss some questions related to that. Okay. So what electron possesses mass and positive charge? I think it is already we have discussed. So what will be the answer? Option A is mass and positive charge, mass and negative charge, no mass, negative charge, no mass and no charge. What will be the answer?
Option B, sir. Option B, mass and negative charge.
Yeah, so mass and positive charge, that is the proton, and mass and negative charge, that is electron. No mass, negative charge. Is there any particle? Okay, so this no mass, actually without mass there is no such particle inside the atom. So we can, or means if it is a negligible mass also, some particle which has a very negligible mass also. Okay, so no mass, there is no such kind of thing is there. So option B is the answer. So electron has a positive what is called mass as well as the negative charge. Okay, so the next things, okay, why is it not changing? Okay. Okay, so how do we calculate the mass number of an atom? So mass number, what is the mass number? Anyone can tell what is the mass number of an atom?
The number
So
of
basic,
proton plus electron plus neutrons.
okay, so basically mass, okay, mass of atom, yeah, so the sum of protons plus electron plus neutron and other particle also is there. So okay, but the atomic, these things, I think mass number of atoms. So what is the mass number? This is not the mass of atom, this is the mass number of atom. So what is the mass number of atom? Okay, so basically if you see there is a representation, so from where you can get the information what is the mass number of atom and and what is the atomic number, all these things. Okay, so basically if I have some element which is x, and you can see that okay, there is some a value, there is some b. So this kind of representation is there. Suppose I can tell that chlorine. Okay, chlorine, what is the atomic number of chlorine? 17. So
17.
yeah, so and the mass number is 35, 1. And there is other things also there, isotope. So I will discuss that thing also little bit later. But For the time being, you can see that chlorine, which the atomic number is 17, and the what is called atomic mass. So this is the atomic mass, and this is atomic number. Okay, so basically mass number of atom, basically the combination or sum atomic
Protons and neutrons.
yeah, atomic number or protons. I can write proton plus neutron. Okay, so that means this B, whatever things is there, that is the proton plus neutron. Okay, so this means in the chlorine case, it is 17 plus 35. That means the atomic number or electron number 17, and proton number also 17, and the neutron, what is the how much neutron? Neutron is 35 plus 17, that is 18. So there is one isotope. So what is the isotope? There is different type in the nuclear, different number of neutron can present. So in the case of chlorine, there is what is called chlorine 35.5 one is there, and chlorine 17 one isotope is there. So different type of isotope is there. So which representing there how much what is called the atom which has a similar type of different number of neutron is there in the nucleus. So number of proton plus number of electrons. So that not the answer. Number of neutrons per number of electrons. So number of protons plus number of neutrons. So that is the answer. So basically it will represent what is there in the nucleus. So if you see the mass, what is the mass of the neutron?
This is the first one could what's the 94.
Sorry.
Huh?
So it is what is called the mass of the neutron is quite high compared to electron and proton. So whatever mass of the nucleus, that is much higher than what is called electron. So for this nucleus
So
is
1.6 and 10 to the power minus 27 kg.
1.6 into 10 to the power minus 27 kg. And I think this one somewhere, yeah, this one is 9.1 to 31 kg it will be. Okay, so this is the thing. So means atomic mass, basically mass number or something, where it is represented in the top or superscript, and that will give you different isotope property or isotopes of the element. If you read in the radioactive radiochemistry, so that time different type of isotope like uranium, all these things they will keep the information about this. Okay, so next question we can discuss that a mu atomic mass unit defined is with 1/12 of the mass of the carbon atom. This statement is true or false? So is this true? Yeah, it is true. So basically means earlier whatever used to discuss, so that is used to scale up with the carbon atom, and with that how much atom is there, because atomic number of carbon is what is called mass number. Mass of carbon is 12 what is 12. So from there we will discuss, okay, if 12 is there, 1 unit is the 12th of the carbon atom. Okay. So with this, whatever we discussed the atomic level orbital, so that things we have discussed. Now after that we'll discuss hydrogen atom spectrum. So there is a different type of origin spectrum is there for hydrogen atom. So this is the hydrogen atom, and there when the you have the different different static orbital where the electron is roaming around the nucleus. So there is a different type of transition you used to see. So like there is the name is there, Lyman, Balmer, Plasman, Passen, bracket, and Wundt series. So basically you have when the high energy state to first quantum number. So this is the principal quantum number, I can say. So we will discuss this principal quantum number later. But if it is coming to N1, then we can tell this is Lyman series, and Balmer is N is equal to 1, and from the higher energy state, if it is coming, then it is called Balmer series, and Paschen is if N is equal to 3, then the Paschen, and the bracket series is N is equal to 4, then it is this thing. So these things, and each state it is a different type of transition is there. So if n is equal to 1 and it is coming from n is equal to 2, means first excited state, then that is called alpha. If it is n is equal to 1 and n is equal to 3, then that is called beta. Okay, this kind of classification also is there. So in that way, alpha, beta, gamma, that kind of spectrum also you can observe. But when we are telling that, okay, someone is unmuted state, so can you please mute your microphone? Okay, Nagaraju, I think, can you please unmute? Sorry, mute your microphone. Okay. Okay. So, but when you are telling the spectrum, that means you can see the spectrum in the spectroscopic region or in the visible or different region. So then, where which region you can see in this all this transition. Okay. So in that case, Lyman series where you can see in UV region. Okay, and this Balmer series, this is in visible region, and Paschen, all other things you can see in IR region. Okay, there is sometimes they will ask the question that in which region you can see the spectrum, IR or IR or UVs or visible region. So you can remember that Lyman and Balmer. So Lyman series in UV region and Balmer which is in visible region, and other all are in the IR infrared region. Okay, and this is the energy of the state. So these things in each state there is electron, and that electron how much energy of that state, that we can calculate from this equation. So basically W is equal to minus 2 pi square z square e to the power 4 mu by h square by n square. So n can be 1, 2, 3, 4. So other particle z is the total number of electrons or atomic number. So all other things you know. So if you know the n1, then you can get to know what is the energy of that state. Now question, suppose I want to calculate what is the transition energy. Suppose one electron is coming from here to here, then what is the transition energy of that? Okay, so that things you can calculate from here. So suppose the first state or ground state, that is W1. So W1 is equal to minus 2 pi square z square e to the power 4 nu by h square 1 by n. For the time being I am keeping n 1 square and the first excited state is W2. That will be minus 2 pi square z square e to the power 4 nu by h square 1 by n1 square n2 square. Now if you want to know the energy difference of these two states, that is del E is equal to W2 minus W1. So that will be minus 2 pi square z square e to the power 4 nu by h square 1 by n2 square minus 1 by n1 square. So this is the equation. Now suppose you want to calculate for Lyman series. In the case of Lyman series, what will be the N1? N1 is the ground state. So for Lyman series, N1 is the 1. Okay. So that means for Lyman, N1 is equal to 1. And other two N2, suppose you have asked that first excited state or second excited state. That case you have to consider these things. So if it is first excited state, then K2 is equal to 2. If second excited state, N2 is equal to what is called N2 is equal to 3. So if it is Balmer series, then N1 will be 2. Okay, so you have to know that which series they are asking. So that means you get to know the transition energy of this thing. Okay, and if daily we know that E is equal to H nu, so we can write here H nu also. H nu also you know that H nu summon C by lambda. So if they ask what is the wavelength of the transition, then we can calculate from here that k lambda k value. Okay, so here we can rearrange these things. So basically E k H nu by k H C by lambda, that is equal to minus 2 pi square z square e to the power 4 nu by h square 1 by n2 square minus 1 by n1 square. Okay, so here you can write 1 by lambda is equal to h cube, and c if it is come here this side, so minus 2 pi square z square e to the power 4 nu by c h cube n2 square minus n1 square. So these things is to call R, which is Rydberg constant. Okay, so this value sometimes in the question people used to give. So from that you have to calculate what is the lambda value for the Balmer transition or Lyman transition. So that things you can calculate from here. Okay, so this from there some question is there, we can discuss from here. So the question is, which of the following statement regarding the spectral series is correct? So the lines in the Balmer series correspond to electron transition for every energy higher than n is equal to 1 energy level. Paschen series appears in the infrared region. The lines of the Lyman series appears in the visible region. Transition from higher energy level to fourth energy level produce a Hund series which falls in IR region. So what will be the answer? Okay, someone Rao H, he has written that option B.
Paschen series appears in infrared region.
What will be the which one is the answer?
B, sir.
B. Okay. So B. Okay. So Lyman. What we have? Lyman, Balmer. Lyman. What is the N1 value is equal to 1, and more than higher energy state, it will come the transition. So it is the, and Balmer N is equal to 2. So it is written Balmer. So that means this question cannot be this one cannot be the answer. So sometimes when you will do the competitive exam, some question also, some option will be there, we don't know exactly. So but some option you know that cannot be happen. So in that way also you can choose the right answer. So for this I will choose discuss all the option that can be happen or not. So that way we can discuss. Okay. So Balmer series, what is the n is equal to n should be 2, and what will be the region? Which region it will be appear? UV is visible region or infrared region? Balmer series. We can see here Lyman is UV region and Balmer is visible region. So it should be in visible region. And so Balmer n is equal to 2. That means A option cannot be happen. The patient series appears in the infrared region. Okay. So patient series here you can see patient n is equal to 3 and IR region it is 2. So infrared region, yeah, option B is correct. So there are sometimes more than one option also is to correct. So you can see C or D is correct or not. Okay. The lines of Lyman series appear in the visible region. So Lyman series where is to come? UV region. Okay, so that means option. So C option cannot be happen. Then transition from the higher energy level to fourth energy level produce the Fun. So Fun series is to come for 5 and bracket is the 4. So this is Fund. So this is n is equal to 5. So that IR region it is to fall. So that is correct, but n is not for 5. So D is not correct answer. So B is the correct answer. Yeah, that is correct. Okay, next question. Wavelength of the Lyman series in the, what is the answer?
Ultraviolet.
Yeah, ultraviolet region. So we already discussed this thing. Okay, so next question. Calculate the wavelength of H alpha line of hydrogen spectrum in the Balmer series given that the Rydberg constant is this one. Okay, so you people can also what is called calculate in your notebook. Okay, so how we can what is called proceed with this question? So hydrogen series means we have to think this Lyman, Balmer, Paschen, all these things. So as I have mentioned, alpha series, alpha when it is mentioned, that means first excited state. Okay. So here it is written Balmer series. Balmer series where Lyman is N1 is equal to 1. It is Balmer N1 is equal to 2. Okay, and as it is mentioned alpha, that means first excited state. N2 is equal to 3. Okay, and we have discussed that 1 by lambda is equal minus 2 pi square h. What I also forgot 1 minus 2 pi square z square e to the power 4. 2 pi square z square e to the power 4 nu by ch cube 1 by n2 square minus n1 square. So these things we have told that R value. This is Rydberg constant. Okay, so this value it is given. So that means all these things it is given. So we have to calculate the lambda value. Okay, so 1 by lambda is equal to R 1 by n2 square minus 1 by n1 square. So R is 109676 1 by n2 is 3 square minus n1 is 2 square. Okay, so what will be the value? 109676 94. So you people can now calculate what is the value it is coming. Anyone can write the answer. Okay, it will be minus is there. This value is R. Anyone can write what is the answer? Okay. Okay, I am not calculating. So this it is written that okay, on 523. So 1 by lambda value is this one, right?
Yes, sir.
Okay, 7. Yeah. So this is centimeter inverse because these two are unitless because n1, so these are unitless, and this is centimeter inverse R value. So when you will do R is equal to this, so 1 divided by 15232.3, this will be centimeter. So in general this series or this lambda value is it is to present nanometer or Armstrong scale. So sometimes in the what is called in your question answer there will be Armstrong and nanometer scale, so you have to what is called convert this unit. Okay, so 1 nanometers means how much? 10 to the minus
10
9.
to the minus 9.
Yeah, 10 to the minus 9 meter. Okay. And 1 Armstrong means 10 to the minus 10 meter. Okay. So if it is centimeter, then 10 to the minus 8 centimeter. So you have to convert sometimes this number. Okay. So these things from the series, this kind of question is to come. So whatever we have discussed here, so that kind of question is to come. Now we will go forward this Sommerfeld theory. So whatever we have discussed in what is called Dalton model or Bohr theory, they have mentioned that it is whatever what is called electron is moving in the static state, but that is in spherical in structure. But first Sommerfeld came and he proposed that no, that is not what is called spherical structure. So it's depend on which kind of orbital is there, and it is elliptical in structure. And when the electron is moving, when it is far away from the what is called nucleus, so this is the nucleus. So when it is far away from the nucleus, it is moving slow, and when it is closer to the nucleus, it is moving fast. Okay, so this is the approach nucleus list, and it is part this is the thing. So different type of atomic what is called orbital structure he has given. So means if it is what is called s orbital or p orbital, different type of orbital nomenclature they have given. So if that kind of thing, then atomic orbital structure is different. Okay, so I think these things professor have discussed more details, and as well as if people have what is called read all these things in your school time. So we can discuss the question answer. So in an atom, the shape of the orbital is like a sphere, like a dumbbell projected in between x, y, z. So and projected towards a corner of the hexagon. Okay, so if orbital structure they have asked. So okay, what we know, we can go forward a little bit details. So one is orbital, spherical like structure. Okay, and how is the p orbital? So p orbital 3 p orbital is to come px, py, and pz. So we have a 3 Cartesian coordinate. Suppose this is px, this is x, this is y. We are representing in what is called 2 dimension. So if it is px, then it is along the x-axis. So this kind of thing is there, and in p orbital we know there is a polarization. So if it is positive side one and one is side negative, and this is called node, where there is no charge or no polarization. So this is differentiating the two positive negative and positive charge. So it is to call node. Okay, so if it is y axis py, how it will be along the py, along the y axis. So this is the node. And how is the x? Suppose this is x and this is z axis, along the z axis. Okay, and if there is a other one is the d orbital. How is the d orbital? 5d orbital is there. How many d orbital? 5d orbital. What is that? D xy, d xz, d yz. Other one is d x square minus y square and d z square.
square.
Yeah. So dxy, what is this Cartesian? So basically if it is x and this is y, so along this, in between this x and y axis, there is a what is called d orbital is there. So there is a polarization. How is the polarization of d orbital? It will be like plus plus or minus minus like this, or it is this is plus, this is plus, this is minus, this is minus. How it will be? Suppose this is A and this is B. Which one is the correct? Anyone can tell? Which one is the correct? How is the dz square orbital? So this is z square along the z, and this is x and this is y. So along the z orbital, this is there. So it is kind of dumbbell kind of structure. It is called not dumbbell kind of structure. P orbital is dumbbell kind of structure, and what is called d orbital. It is along this x and y z, and this what is called f orbital in general x y z. So 3 Cartesian is to come. So it is in the hexagon 6, projected toward the hexagon corner of the 6. So it's difficult to present here. Drawing it's difficult. So but I think you must have seen in the professor lecture. So for this I am not what is called drawing this thing, and it is difficult to represent in the 2 dimension also. Okay, so but at the end I will discuss ask you can think that okay, how is the structure of this orbital. It is positive positive negative negative or this kind of thing.
A.
Huh? Which one is correct, A or B? Okay, so actually this one is the correct. A is the correct answer. Okay, so this is not. This is not. Okay, this one is the correct. So this kind of things is there, and this dx square minus y square. So this is along what is called x y axis. Okay, so this will be like this. This is x, this is y. So this kind of thing. Plus plus. Okay, so 5d orbital is there. How many f orbital is there? How many f orbital? 7 f orbital is there. Okay. Okay. So we can go next question. So isotopes with even number of neutrons are more abundant compared to nuclei contain odd number of neutrons, less abundant compared to nuclei contain odd number of neutrons, right? And equal compared to nuclei contain odd number of neutrons. And that last option is all of these. Which one is the correct answer? This question, I think in the what is called video, it is mentioned. Even number of neutrons. It is more. Option A, more abundant compared to nuclei, which is the odd number of neutrons. Yeah. Okay. So I think these things we have discussed already. So now we will discuss the different type of number, what is called principal quantum number, and orbital quantum number or angular quantum number. Okay, which is represent L, then magnetic quantum number AM, and spin quantum number S. Okay, and each state we want to know the energy, then we already discussed this is the energy equation. So from here we can calculate the energy. Okay, so now I think what is called principal quantum number, basically K1s 2s we have carried. So this number, this is called principal quantum number, which electronic state the electron is there. So depend on there that the principal quantum number is coming. So suppose we have the nucleus, and along with that there is different static orbital is there. So in which state the electron is there, depend on that the quantum number is defined. This is n, this is n, suppose n1, n2, this is the principal quantum number. If n is equal to 1, people is to, this is k cell or something, k, and if it is 2, then l. So that kind also nomenclature is there, k, l, m, k. We already also know these things. So k, l, m, this thing is there. Now this principal quantum number and angular quantum number, what is the value? So this angular quantum number L will be less than the principal quantum number. So n if n is equal to 1, n minus 1 will be the what is called value plus minus n minus 1, that will be the value of L. So if you have the it is written here also. So if you have n is equal to 3, then you have what is called L value will be n minus 1, that is 2, 1, 0. Okay. So this is the what is called angular quantum number. So depend on that how you are defining, we can define the orbital, which orbital the electron is present. So if n is equal to L is equal to 0, we denote that s orbital. If L is equal to 1, then we can tell this is p orbital. And if L is equal to 3, d orbital. If I is equal to 4, then sorry, not I, L is equal to 4, that is F orbital. So these things I think we people know. And M value is plus minus magnetic quantum number plus minus L value. So if S orbital L is equal to 0, M is equal to 0, and P orbital L is equal to 1, so M is equal to minus 1, 0, and plus 1. And next one is the spin quantum number. And for the spin quantum number angular momentum, we can calculate from this equation. So for each orbital, whatever quantum number is there, from there you can calculate the angular quantum number. So sometimes it is to give the question from this equation. So to calculate the angular quantum, what is called angular momentum of that electron or velocity electron. So that things you can calculate from this equation. So and how to what is called refill the how the electron is to go in the energy state, so that this equation what is called this orbital it is to follow. So these things I think you people know. So we can discuss some problem. So there one question is, which of the following can be a set of the 4 quantum number of the principal of the valence electron of rubidium, which atomic number is given here. So which one will be the answer? So this question, how we can proceed? Rubidium.
Option B.
Okay, option B. One is telling option B. So these things what you can proceed, Z is equal to 37. So first we can define the electronic configuration how it is. So 1s2, 2s2 with that. So we can tell that what is called 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Okay. Then what is the how many number of electron? 2 to 4, 10, 8, 10, 10, 20, 30. Then 4p, 6, 5s1. Okay. So this thing you can easily you can write that up to this. This is the what is called chromium case. So you can write chromium and 5s1. Okay, so that means from here, what is the principal quantum number? N is equal to 5. So, but for all the case n is equal to 5, so we cannot differentiate still now what is the answer. Now s orbital, for s orbital L is equal to what is the value? L is equal to 0. So that means what is called, we can different, you can see that L is equal to 0, option A and D. That means B and C is gone. Okay. Now we have to think about A and D. Okay. So if L is equal to 0, then what is the value of M? M will be 0. So still now we can see M is equal to 0 and M is equal to 0 both cases. But if there is a some S value, what is the S value? S value plus minus half.
Plus
It
half.
can be. So if it is plus 1, what is called 1 electron is there, then it will be plus half. If 2 electron is there, then 1 electron is plus half, one other electron is minus half. So this is basically represent the spin state, how it is. It is what is called clockwise or anti-clockwise. That kind of information it will give. Okay, so that means option A is the correct answer. Okay. So these things is there, but so what is called? We have to first what is the electronic configuration. So that things you have to think. Okay, so this kind of question also it is to come. And next question is 1 electron volt of energy is equivalent to a photon with a wavelength about what? One EV is equal to what is the photon energy wavelength. We have to calculate the wavelength. So how we can proceed? Anyone can suggest how we can proceed with this? We have discussed already. Sorry. Where we have discussed? Here. So we have discussed here. We have discussed here, no? Here. So we have to think in that way. So we know E is equal to H nu. What is H? What is H? H is the Planck constant.
Planck's constant.
So H C by lambda. What is lambda? Lambda is the wavelength. Okay, so we have to calculate the wavelength. We have what we have given. We have E. H we know Planck constant. What is the value of Planck constant? Anyone can tell?
6.625 10 to minus 34.
Minus 34 joule. Okay. So this is what is called Planck constant. And C, what is the C? C is the speed of light. Minus or plus? Ten to the power 10 centimeter. Okay. So from here we can rearrange lambda is equal to hc by E. So you can write 6.26 into 10 to the minus 34 into C 3 into 10 to the minus. You can write in SI unit 10 to the power 8 meter square. Now E 1 EV. So 1 electron, so how much is the K energy? 1.6 into 10 to the minus 19
Coulomb.
Coulomb. 1.6 into 10 to the minus 19 Coulomb. So this way you can calculate what is the K energy. Okay. So whatever energy it will come, you have to convert in Armstrong. Okay. So next, what is there? So you can answer this question. Gamma particle possesses mass and positive charge, mass and negative charge, no mass and no charge, mass and no charge. Option A, mass with positive charge. Option B, mass and negative charge. Option C, no mass, no charge. D, no mass and no mass and no charge. So we have a alpha particle.
No mass, no charge.
Okay,
Mass
no
and
mass.
positive.
Because it's an electromagnetic wave.
Okay, gamma. Okay, let's see. What is the alpha? What is the charge?
Positive.
Alpha
Helium.
positive charge.
2He4.
2He4. Yeah. Then what is the beta charge?
-1.
-1. Okay. So gamma, what is gamma?
0.
So no mass, no charge. Yeah, electromagnetic particles. So it has no mass, no charge. Or it has a negative charge.
Yes, no.
Negative.
Huh?
So alpha and beta are particles, but gamma is a wave.
Yeah, so it has no mass, no charge. Option C is the answer. Correct. Okay. So one question is, if the nitrogen atom has electronic configuration 1 is 7. So because atomic number of nitrogen is 7, means 7 proton is there, so 7 electron will be there. Okay, so 7 electron is there, then how is the configuration? It is telling that if nitrogen has electronic configuration 1s7, it would have energy lower than that of the normal ground state configuration. So this is the normal ground state configuration of nitrogen, because the electron would be closer to the nucleus. Yet 1s7 is not observed because it violates which? There is 3-4 what is called principle is there. So which one is violating? Anyone tell?
Pauli exclusion.
Pauli exclusion principle. Yeah, it is correct. So Heisenberg uncertainty principle, what it is to tell?
The path of the electron is uncertain.
Yeah, so the what is called Heisenberg uncertainty principle, it is to tell that one cannot what is called calculate the position as well as what is called P means velocity in mv. So that cannot be calculate or that cannot be measured at a same time. Okay, and these things del x position and del pv momentum, which is greater than equal to h by 4 pi. This is the Heisenberg uncertainty principle. Okay, and what is the Hund's rule? Can you tell what is the Hund's rule? What is the Pauli exclusion principle? That 2 electron does not have same quantum number. Okay, so that is the principle of the Pauli exclusion principle. What is that means? If you have the what is called 1s7, because in s orbital, what is the n value? In this case, n is equal to 1. So s value l is equal to 0. So m value, it will be 0. So s value plus half and minus half. So that means this is, if it is 1 electron, another electron will be this, but we have extra 5 electron. Okay, so extra 5 electron, then it will be the same key quantum number. But in the second state, so this can be a lower energy orbital, but what is called, this things is the what is called violating, this thing is violating the Pauli exclusion principle. But in next case, it will be different for different k electron, because if you see the valence electron p orbital, so 3 electron is there. So n is equal to, what will be the n is equal to 2. What is l value? L value minus 1. It will be 1. So p, for p orbital, l is equal to 1. M value, it will be plus 1, 0, minus 1. Okay. Then for S, it will be plus, for each state we have plus minus half. Plus minus half means 6 electron can occupy. So here we have 3 electrons. So 3 electron, for 3 electron, the quantum number k will be different, because if you see the 3n, all the case n is equal to 2, but l, what is the l value? So l value, it will be 1 for all the case, but n value, m value, it will be different. One for 1 electron, it will be plus 1, another electron 0, and other electron minus 1. So if s is equal to, for all the case, half plus half, but the m value is different, so it is violating the Pauli exclusion principle. And Hund's rule, what it is to tell? It is to tell that electron will fill from the lower energy state to higher energy state. That means first it will come on, then 2s, then 2p, like this. So I think this is the, this things is, so this is, it will follow the Hund's rule. Okay. And Bohr postulate of stationary orbit. So Bohr postulate does not tell anything about the how the electron will refill all these things. Okay, so this is the thing. Then we have learn about the solution, all these things. So there is a question, the term parts per trillion means what? Okay, so what is the meaning parts per trillion? There is different kind of things as there. So this question we will discuss little bit later. We can recall the things. Okay. So we have learned solution. What is solution? Suppose you have a sugar and you put in water. Suppose in your house there is some guest came and you want to give the cold sherbet, that kind of thing. You add sugar in the water, so that is called solution. Okay, in simple word. Okay. And it is called solute. What is the solute? So this water, that is called this water. This is called solvent, where you have the what is called and sugar, that is called solute. What is solute? What is solvent? Can you tell what is solute and what is solvent? So basically solute is what? It is written that invisible component in the solution called solute. So basically suppose you have the solution. So where the amount of the component, you have two component A and B. Okay. And whichever amount is less and its physical property will not match with the solvent but in not solution. So that is called solute. And in what is solvent, where the amount of that component is high and the physical physical properties of that component is same at with the solution, so that is called solvent. So in this case water, which is a liquid state, and solution which is also liquid state. So that means water is the solvent, and what is called sugar, which is a in general it is solid, but when it is dissolved in water, so it is become a liquid. Okay, so that means it is its physical property is not matching with the solution, so this is called solute. Okay, so this is school level chemistry. And there is different type of unit we have discussed, which is when we will discuss some electrolyte or something. Suppose someone told that you make the solution for the experiment, some concentration they have mentioned. So different type of concentration unit is there, like mass percentage, where you have the component in solution in mass and the total mass of the solution. So there is different type of mass percentage is there. That is weight percentage, means both solute and solvent you are taking in same mass. Okay, so in the case here, so sugar you have taken suppose 10 gram, and it is called water you have taken also 10 gram. Okay, so that means the and so this is the percentage, as for this it is divided by 100. So suppose 10 gram of sugar you have dissolved in 10 gram of water, then it will be weight percentage by weight percentage, total mass of the solution. So 10 plus 10 into 100. Okay, so that means 10 by this is called 20 into 100, so 50 weight percentage. Okay, it is to written like this. Okay, so this is the mass percentage. There is also volume percentage, mean similar volume volume of the what is called in the case of two mixture of solution, two mixture of what is called liquid. Then in this case, in that case, volume percentage you can take. So volume of the component by divided by total volume of the solution, how much volume is there. Okay, so that way also you can say. So next is the mass by volume. So one you have taken the solute mass, and other one is the ml, 100 ml, how you have dissolved. Okay, so suppose you have taken 20 gram of sugar and you have dissolved in 100 ml of water, then that is called mass by volume. Okay, and the parts per million is one parts of the component or solute dissolved in 10 to the 6 parts of the solution. So this is parts per million. Okay, and parts per billion is 10 to the 9, and parts per trillion is 10 to the 12. Okay, so this is also it is to call microgram per ml, and this is nanogram per ml, and this is picogram picogram per ml. Okay, so this is the thing. And now we have the mole fraction also. The mole fraction of the component, basically number of moles of the component total by the total number of moles in the component. That means suppose you have a component A and this is component B, and how you can calculate this, that if it is 5 gram and this is 10 gram, then the mole fraction of A So that how we can get? So this is A, and it is molecular mass is suppose 50 gram per mole, and B molecular mass is 100 gram per mole. Then you have to convert the mole to that. So how you can convert? Whatever mass is there divided by the molar weight. So in the case of the A, the mass Na we can write Na is equal to 5 by 50. So 1 by 0.1. Okay, 0.1 mole. And what is the B? So B is 10 by 100. That is also 0.1. Okay. This is the mole. So you get the mole of Na and Nb. So basically mole fraction what it will be for A, Na by Na plus Nb. So if you have given the weight of that compound, then you can get the mole fraction of that molecule. Okay, there is the molarity also, moles of solute divided by volume of the thing. So molality and molarity, all this thing is there. So now we can discuss the question. I think now if people can tell what is the terms parts per trillion means. Anyone can write. What is the parts per trillion means?
The fourth option.
Fourth option. Microgram per liter. So actually the thing is parts per million picogram per meter, I think. This is the parts per trillion, no?
It's a picometer.
Huh?
The picometer, sir.
So this one. Picogram per ml. So if you tell the picogram, microgram per liter, then what will be microgram per liter? 1 liter means 1000 ml. So microgram by 10 ml. So it will be how much? Nanogram per ml. Okay. So nanogram per ml means
10 to the power 9 minus 9.
Okay, so that is the thing. So this A option will be the correct answer. So next question is, during any physical or chemical change, the total mass of the product is equal to the total mass of the reactants. So this is called, this is very easy.
The law of mass.
Law of
conservation of mass.
So if it is there is a energy conservation is there, then you can tell that law of conservation of energy. And if mass and energy both are conserving, then law of conservation of energy and mass. Okay, so the option A is the correct answer. Okay, so now we can go to the next part. So there is a different type of principle is there, Law's principle. So basically when you will make the solution or you are mixing the solute and solvent, so there is different type of exothermic, endothermic reaction is to happen. So what is the exothermic reaction?
The reaction in which energy is released.
So when the energy is released, that is called exothermic reaction. And if the energy is consumed, that is called endothermic reaction. So people, what is called? So last principle is to tell that. So if you have some system and you are applying some external force in that system, then the system will respond that way, that whatever external force you have applied, so that can be compensated. Okay, so suppose you have it will be easier. So suppose you have A and you have A plus B, it is going to C plus D. One reaction is happening and it is a exothermic reaction. Okay, and it is happening suppose 25 degrees Celsius. Now question, suppose I make the what is called temperature 50 degrees Celsius, then what will happen? The reaction will be fast or the reaction will be slow? Did you and what is called and sorry? Option A, reaction will be slow, or option B, reaction will be fast. What will be the answer?
First.
It will be
I think,
fast.
sir, slow.
It will be slow. Okay, so two option is came, so we can understand in this way. So in what is called A plus B, it is forward direction. Okay, so in forward direction 25 degrees Celsius exothermic reaction means what is called energy is releasing. Okay, now energy is releasing means what is called heat is going to outside. Now when I will increase the temperature, that means you are giving the heat to the system. Okay, so when you are giving the system heat, then what the system will do? So it will try to decrease the what is called temperature or heat. So which way it can decrease the heat? If the forward reaction will happen, then from the system the heat will come out from the what is called environment. So that means the system will respond in that way where the heat can be released outside. So and in this case what we can see that when A plus B forward reaction is going on, the heat is going out. That means the system energy is decreasing. So the answer will be fast. Forward reaction will be fast. That means the reaction will be happen very high rate. Okay, so this is means the last eternal principle. It is to like this, and what is called, there is other type of different law is there like Henry's law. So and Henry's law say that the what is called, what is the partial pressure of the gas if you have a solution. And in general if you have the water molecule or water, so usually in top of that solvent or water, some water vapor is to there. So and in that, sorry, in that vapor it is in equilibrium with the water surface. So what will be the pressure or partial pressure of that gas? So that can be what is called measured by the Henry's law. So they told that the Henry's law, so the statement is like this, that the gas in the directly proportional to the partial pressure of the gas present above of the surface of the liquid or solution. Okay, so which can be expression this kh p partial pressure, that is kh into x. So x is the mole fraction of the molecule. So these things you can calculate different mathematical problem is to come in this case. So if they have given the mass, from there you can convert this x value, and after that if they have given the kh Henry constant, or sometimes they used to ask to calculate the Henry constant also. So this kind of problem we will discuss in the next class. But this class we will discuss only how what are the principle is there. So after that in the next class maybe we will discuss about how we can calculate the Henry constant, all these things. Okay, so this is one law. There is a Raoult's law. Raoult's law basically what they will tell that what is the partial pressure of each component. Okay, suppose you have A and you have B, and you are mixing these two together, then in the mixture what is the partial pressure of that each component. So that things they can calculate this one. So P1 is the partial pressure of component 1, and P2 is the partial pressure of component 2. Then what will be the partial pressure in that mixture, that is P10. This is the partial pressure or pure pressure when the this is pure component, and it is the multiplication of the mole fraction. Okay, so that is the thing, and the total pressure, it will be P is equal to P1 plus P2. Okay, so this is Raoult's law. So, and one thing I want to tell, that this all this Raoult's law or Henry's law, all this thing that is applicable for ideal solution. Now question, what is ideal solution? There is another called Dalton's law, but before that I want to know what is the ideal solution. Okay, someone message that anyone WhatsApp group link to send. I did not get Harish. Harish, can you unmute and tell what you want to ask? Okay, I think some WhatsApp group link or something he is asking. I did not aware about WhatsApp group, all this thing. So I think they have forwarded this meeting link to you or some other student also. So I think they got all these. They can join with this meeting link. I want to know one thing, that in this meeting link, so everyone can join, or I have to admit them, or anyone can admit them. I want to know that things. Then I can change the setting and I can give the permission to all people. Okay, so I'll check that one. We can continue. Okay, I think we have very okay less time. So I think we are almost done. So basically, Dalton's law, basically whatever I have told here. So this is called the Dalton's law. So basically, the total pressure is the partial what is called combination of partial pressure of each component. So P1, P2, P3. So in this from this part, different type of problem is to come. So means we have to think that what they have given in the question and what you know. Okay, suppose they ask something, and in that equation what are the component is there. So like P is equal to KHX. So you know the X value, but AO what is called, or maybe directly they have not given the X value, then you have to somehow calculate the X value or KH value, suppose they want to know. So that case, what is called, you have to find out the way, what are the terms or what are the parameter is given in the in the question. Okay, so that things you have to find, and this is the Dalton's law. So basically, whatever I have mentioned, so they have taken two mixture where x1 that is when one component, this is the mixture of two component. One is x1, what is 1, and other one is 2. So they have mixed these two solvent, solute, whatever. So they have mixed, and if it is the x1 component is the full, then the whatever partial pressure, that is the P10, and if it is x1 is 0 and x2 will be 1, and whatever partial pressure, so that is K2. And if you add this thing, the total pressure will be P1 plus P2, and it will be linearly increase. Okay, so now the question is ideal solution, whatever I have mentioned also, or I have asked earlier. So ideal solution which follow this Raoult's law means what is called, suppose you have make one solution, you have two component, one is A, other one is B. Okay, and the mole fraction A and B x B. So now if you have only pure A, then on in the A there is a particle is there. So there is the AA interaction will be there. And if B, there is a BB interaction will be there. Now we mix two things. Now what will be the extra thing? AB interaction will become. Is it? Now this AB interaction is there. So now question, if this A and B interaction, it is equal to the AA interaction and BB interaction, say then it will be called ideal solution. Okay, so in physical or mathematical term, you can tell that which solution, the solution which follow this Raoult's law, then that is ideal solution. Okay, so I think this is the thing, and I think this is the last question maybe. Okay, yeah, so this is the okay, this is the last question. So in a chemical reaction, if it mention a STP, means standard temperature and pressure, it implies that temperature, I think someone Rao is mentioned that it option A. Yeah, I think this is the correct answer. So temperature 273.15 Kelvin, that is 0 degrees Celsius, and the pressure is exactly 1 bar. Okay, so this is the standard condition. Okay, I think these things we people know. I want to know what is called. If you people have any suggestion that can be better way we can discuss and better way you can learn the topic. So if anyone want to tell something or anyone have any question, then they can unmute and directly ask. Other thing I want to know that you people means which standard, you all are BSc level or MTech level, or it is what is called higher secondary standard. Means whoever is there, maybe there is so many.
Masters in chemistry.
Okay, you are in masters in chemistry. Okay, because there is so many different means from different stream people will come maybe. So yeah, but we have to keep little bit simple, and if people can tell if we can improve, I can improve the discussion, or what do you want to know more about this question answer, means whatever previous year assignment is there, only that things if people want, or some extra question also which can came in jam or net or JEE main, that kind of question also you people used to prefer to discuss. So that kind of whatever if people suggest on that basis, I will make the changes. Okay, and if any other question is there, then directly ask.
Sir, does it have a particular syllabus or?
Actually, it whatever it is there in the program, that is there, because it is NPTEL course, so professor will decide what are the topic is means it is there. But if you tell the electrochemistry part, there is it is a vast topic. Okay, so it does not has any what is called such syllabus. But for this purpose, whatever electrochemistry in what is called pollution control, that part, so there is some syllabus is there, means whatever it will be there. So some cyclic voltammogram, all these things, so that part will be there.
Okay.
So any question? Anyone has any question?
No, sir.
Sir, you can share us the previous year questions PDF through mail.
Okay, actually, whatever question previous year means exam question you are asking or assignment question?
Yes, sir. Exam question.
Okay, exam question I don't have. I have only the assignment question because that question they did not share with me. So, but I think it is called whatever they will discuss in the class as well as in the what is called this discussion session. So from there only they will give the question. Okay, but I don't have previous year questions. So, but all these PPT and video, all these things I'll share with them, so they'll forward to you people. So that is sure, but I don't have a previous year exam question. Okay. And if anything means you can suggest you people. So whatever way I can, what is called, if any session.
Exam will be in MCQ form.
Sorry.
How will be the exam in MCQ form?
Uh, I exactly don't know what is the. I think they will instruct you how it will be. So I think in the first when you assign the course, that time they did not mention how it will be the question. I think they have mentioned that from the assignment there is some 25% weightage or something will be there, and from the class test, all these things, attendance, all these things, there is a percentage of mark, and in that only I think they have mentioned how it will be the question, MCQ question or writing kind of question. So I think that things they have mentioned, I think. Mm.
So,
Okay, so I think it's almost 8 o'clock. So the time is almost over. So to next week, same time we will meet again. And you, if you have any question or anything, I can write my email. So if people can send the mail also, if you have some doubt. Okay, so I have
okay,
in the chat box I have written my email ID, so you people can write the mail directly to me if you have any question, or if you want to know about the research, how people used to do research, or what are the what is called exposure is there. So if people want to know, so that also you can mail me. Okay, so whatever way I can help, I can help you. And if you have any question, anything, you can send the mail to me. You can give the what is called this coursework name, so that I can get to know that who is sending the mail. So as quickly as I can reply to them. Okay. So we can Okay, so anyone want to tell something? Okay, so okay, thank you everyone, and we can meet next week. Have a good day, good night all. So we can conclude the session. Okay. Okay, bye all.
Thank you.